Hello everyone, welcome back to the channel. Today we'll be talking about converting from a non-linear equation to a linear form. All right. So if you haven't subscribed to the channel at this stage, please do so. It will really help me. Right, let's start. So consider you have been given, let's say, y equals ax squared plus b. What would you say this function or this equation is? Well, this equation is a quadratic, right? So if we were to sketch this on our xy plane, then this is x-axis, this is our y-axis, then we would likely get something like this, okay? Where this is our ax squared plus b. But this is not a linear, it's a quadratic like we have already established, since it has the highest degree of being 2. So we want to change from this to something like y equals mx plus c, okay? Right, that would be the linear. So if we are to sketch this linear, it could be either this line or that line, all right? Okay, so how do we do that? Well, on this particular axis where it is lowercase of x and lowercase of y, whatever you sketch, you are going to get this particular quadratic, all right? So the thing that you need to do is to change the axis. How do we change it? Well, you can still have your xy axis, but the straight line that you want to get would rather be in the form capital Y is equal to sum m, which is the gradient, capital X plus c. So for instance, if we are to sketch on this axis, you have your capital X and then your capital Y. When you sketch, then you can get something like this or something like that, depending on the gradient. So the real question is, how do we move from this stage, okay, to that particular stage? Okay, now all that you have to do is to ensure that if we are given y equals ax squared plus b, is to just change the axis, okay? So if we are changing the axis, then we can say that, well, we want to convert what we have here in the form y is equal to sum mx plus c. Now, if you compare the coefficients, you can say that our big Y is now the small y, right? Our gradient is now a, and then our big X is the x squared, and then c is b, okay? So indeed, you have expressed this quadratic in the linear if these values are equal to each other, okay? So that's basically what you do. But in this video, we'll be talking about how to do it algebraically, okay? How to convert from this stage to that stage, all right? So now let's start with the first question. You are asked to convert what we have here into this form, okay? Now, at a glance, you have y is equal to ax plus b over x, all right? This is not in the linear form. So what you want to do is to look at this particular linear form. It has a constant c. So just make sure that you will get a constant from this expression. That's all you want to do, all right? Make sure that you get a constant. Now, how do you do that? Well, you can first decide to multiply through by x, right? Since this x is the fraction, the denominator. So just multiply through by that. You are going to get xy is equal to ax squared plus b. All right. Now, if you have this particular expression, you can compare this with our y, okay? Big Y is equal to m big X plus c. And you can say that when you compare, your big Y is actually xy. And then your m has become a, right? And then your big X is x squared, and then your c is equal to b. Now, that means that you have basically written this expression, this quadratic thing, okay, in the linear form. If you see that this is equal to this, the gradient is also this, this is that, and here is there. That means that you've written it in the linear form, all right? Because the highest power of x will be just 1. But there are so many ways to really go about this particular thing. This is just one of the methods. So let's call it method 1. Method 1. That's how we got a constant from there. Now, method 2. You can also get a constant, okay? You've been given y is equal to ax plus b over x, right? So what if we decide to divide 3 by x, okay? Because we want, this time around, maybe we want the a to be the constant. So if we divide 3 by x, the a will stand alone, okay? What if we want to do that? Well, you are allowed to do that. So we will have y over x is equal to a plus b over x squared, okay? Now, in this case, you have a constant. You have achieved a constant. So that's the point. Try and make a constant, get a constant from the nonlinear that you've been given. Once you do get a constant, it's easy. Now, you can compare this to y is equal to, let me, in fact, rewrite this thing well before I do the comparison. If I rewrite it, I have y over x equals b into bracket 1 over x squared, right, plus a. Okay, now let's compare this with y is equal to m big X plus c. Okay, if we do compare, now we can say that, well, this thing is in linear form. Why? Because this is that, this is also what it is, this is here, and a is there, right? So we can basically say that this is in linear form because our big Y stands for y over x, and then our big X, or let's say our gradient, is b, and then our big X is basically 1 over x squared, and our constant is a. Okay, so we have written it in the linear form. So the clue is that use algebra and get a constant from what you've been given. Just obtain a constant, okay? Because any linear that you are given, there are two things you are looking for. One, the highest degree of this x term should be 1, and then there should be a constant. A constant can be 0. Why not? Right, let's consider question number 2. In this case, we've been given x is equal to axy plus by, okay? And then they want us to write this in this particular form. So I want to get a constant. What do? Well, why don't I divide, okay, through by maybe y, so that the b will become my constant. Okay, so if I divide through by y, then what happens is that this y will cancel that y, this y will cancel this particular y. So my result is going to be x over y is equal to ax plus b. Okay, so this particular thing could be compared to y is equal to big Y, okay, is equal to small m big X plus c, where this is that, here is also there, all right? So definitely, if you are saying that this particular expression or equation can be written in this form, then indicates that where your big Y is actually x over y, and then your gradient is a, and then your big X is small x, and then your constant is the b, okay? And then you are done. Let's consider another example. What if we are given this question? Convert 1 over y is equal to a root x minus b over root x, okay, to this particular form. Well, it follows the same argument. Can we get a constant? So that you start to think of a constant. Now, they told you that a and b are constants, okay? But it happens that with all the constants, there are variables, okay, attached to them. So we need to let one of them go. All right. So if we have 1 over y is equal to a root x minus b over root x, then you may be thinking, well, can I just multiply through by maybe root x so that the b now becomes my constant? Well, yeah, you can do that. Okay, so we are going to have 1 over y, and then we have a root x minus b root x. Okay, let's multiply through by root x. So let me just use dots for my multiplication. Root x, root x, root x. All right, so when you do this, what happens is that we get root x over y is equal to ax. Okay, since root x times root x will give you it's like this half, all right, they multiply, you add the powers, so that's 1. That's how come we write this. Okay, all right, so let me clean that. All right, so and then this will now be, this will cancel that, so we'll be left with only b. Right, so we can also say that what we have here, we can compare it with y is equal, big Y is equal to small m big X plus c. All right, and the point is, from the beginning I told you change the axis. Yes, because these axes are in small y and small x, but now you've changed the axis to big Y and big X, hence you are getting the linear. Okay, but this is only true when you have your big Y to be equal to root x over y, and then you have your big X to be equal to small x, your gradient is equal to a, and then your constant is equal to negative b. Well, there are several ways to actually do this. Someone can say that, well, from the beginning, we were given 1 over y is equal to a root x minus b over root x. Someone will say that, well, instead of multiplying through, you see, in this example, what I did was to multiply through by root x. Someone will say that, why don't we divide through by root x? Well, you can do that when you divide through whatever that you are trying to do. If you decide to divide through by root x, it means that the a will now become your constant. Okay, so like have the liberty to play with it. Just try and get one constant from the expression or from the equation and you are good to go. All right, now I want us to look at situations whereby they are not even though they are non-linear like what we have here, but they come with some kind of exponents, okay, in the exponential form. So let's start with this particular question. We are given y is equal to 10 ax plus b. All right, so if you have something like this and they want you to express it in this particular form, how do you do that? Well, you can, since it's exponential, you can just take log of both sides. All right, so you have log y is equal to log 10 ax plus b. Now note that when you write log on its own, it is to the base 10. Okay, all right, so we can apply the laws of log over here. So log y is equal to ax plus b log 10, but log 10 is actually 1, so that just gives us log y is equal to ax plus b. Okay, so once you have written it in this form, you can compare it with y is equal to mx plus c. Okay, and this x should be bigger, all right, bigger than what you have, and a y should also be bigger than what the question was given. Now, you can, once you write something like this, it means that you are arguing that, well, there's some sort of constant there. You've achieved a constant, and there's a constant here, so you can compare the rest. Okay, that's the argument. So y, big Y is equal to log small y, and then your gradient m is actually a, and then your big X is small x, and then the c is the b, and then you are done. Okay, you have written it in the linear form. All right, let's consider our last but one example. We want to convert what we have here in the form, all right, in the form y equals mx plus c. Okay, now if you are given something like x to the power a, y to the power b is equal to e to the power 2. Once you see e there, I would advise you to instead of using log, use the natural log, okay? So let's take the natural log of both sides. We have ln, or the natural log of x to the power a, b to the y to the power b is equal to the natural log of e to the power 2, okay? Now, I hope you remember your logarithm. If you do not, well, I have a full video on logarithm, every topic that there is in AddMaths on the channel, so you can check it out. Okay, so applying the law, we will have the natural log of a to the power, x to the power a plus natural log of y to the power b is equal to 2. Y is equal to 2 because if you have the natural log of e to the power 2 is the same as 2 natural log of e, and natural log of e is 1, so the answer is 2. Okay, now we want to write it in the form y equals mx plus c, so let's move this particular one to this side, okay? So we are going to have, but before we even do that, I think we have to apply another law. So we have a ln x plus b ln y equals 2, okay? Then we can move it. So we have b ln y is equal to negative a ln x plus 2, okay? So now we have achieved our constant, but there's one more thing that we can do. We can decide to divide both sides by b, okay? So this will cancel that. So that will give us, let me clean this one and continue the argument here. Okay, so that will give us ln y is equal to negative a over b ln x plus 2 over b. Now, you remember that we were told that b is a constant, so that makes the whole of this a constant, all right? So you have achieved a constant, and therefore you can compare it with y equals mx plus c, okay? Plus c. Now, that means that your big Y is basically ln y, and your gradient is negative a over b, and then your big X is ln x, and then your constant c is 2 over b, and then you are done, okay? This b is nasty, let's write it well. Okay, and you are done. So basically, this is how to approach a question like this. When you say don't panic, apply everything you know in mathematics, okay? Trying to get a constant out of the equation. That is the plan. When you do get a constant, you compare it with y equals mx plus c, and you are good to go. Now let's look at our final example. So we want to convert y is equal to a e to the power bx. Okay, we want to convert this particular thing to y equals mx plus c. How do we do that? Well, first you want to divide through by a. Okay, so you have y over a is equal to e bx. Now, once you have this, there is no coefficient of the exponential function, this one. You have to ensure that there's nothing here. That's why I divided through by a. So if there's nothing here, then it becomes easier for you to just take the natural log of both sides. Okay, so you have ln y over a is equal to ln e to the power bx. Then you apply the division law of logs. So you have ln y minus ln a is equal to bx, okay? then you can move this particular thing to the other side. So you have ln y is equal to bx plus ln a. Well, we were told that a and b are constants, so that makes this thing a constant. Okay, this whole thing, ln a is a constant. Now, if we compare with y is equal to mx plus c, then we can see that our y, our big Y, is definitely ln y, and then our gradient is b, and then our big X is small x, and then our constant is ln a. Okay, so this is how we change from exponential or a non-linear to linear. Point is, try and get a constant from the equation. Okay, once you get a constant, then you can say that, well, I have changed the axis from small y and small x to big Y and big X, and compare those essential elements there, and then you are done with the question. Right, so the next time that we talk, I'll be talking to you about the reverse, where you are rather changing from linear to nonlinear. Today we've changed from nonlinear to linear. The next time we talk, we will do the opposite, where we change from linear to nonlinear. Until we meet again, stay safe.